Okay, we just did page 34 with our warm-up, so this should be going on page 35. Your title is Similar Figures. Our objective, I will be able to apply the concept of proportionality to identify similar figures. Okay, corresponding angles are angles in matching corners. Okay, here's a picture of two similar figures. Okay, obviously the one on your left is bigger than the one on your right. Corresponding angles mean on the same side. So I highlighted in red. Okay, angle A is on your left side and angle X is on your left side. So those are corresponding angles. Okay, corresponding sides are sides in the same position on different figures. Okay, so here our left figure is bigger than our right figure. I highlighted with red our left sides of the rectangle. Okay, so since these are both on the left sides, those are corresponding sides. Okay, so J to K corresponds R to S. They're both on the top. Okay, K to L that I'm highlighting corresponds S to T. They're both on the right side. And then side M to L corresponds U to T. Okay, similar figures are figures that are the same shape but not necessarily the same size. Okay, corresponding angles are congruent. Corresponding sides are proportional. For example, okay, here's our first one. We have similar figures. Same size, different shape. Same here. Two right triangles, same size, different shape. Okay, and then you'll see this last one where you'll have a triangle within a triangle. But still, you still have two triangles. Same size, but a different shape. Okay, non-examples. We have two triangles, but one looks like an equilateral and one's a right triangle. This one does not work. Okay, our second one, we have a rectangle and a diamond. All right, within versus between ratios. Okay, with these, it doesn't matter which one you use. Just use the one that best works for you and which one you understand better with. Let me see. Okay, within means a ratio is set up with two sides from the similar figure. Between is a ratio that is set up with two corresponding sides from different figures. Okay, let me backtrack. Okay, I'm going to show you an example of the within first. Okay, so within says ratio is set up with two sides of the same figure. Okay, so I'm going to look at our smaller triangle first. Okay, I'm just going to mark side BC and then A to C. Alright, what it means from the same figure. So, I marked side BC, which is 6. Okay, it's from my smaller triangle. And then the other side that I marked is side A to C, which is 7. Okay, so this is side A to C. Our 6 is side B to C. Okay, this is what it means that it's from the same figure. Okay, it's both from that same triangle. Okay, now I'm going to look at my larger triangle. Okay, with our larger triangle, we had BC for our smaller one, so the one that corresponds to that BC is E to F. Okay, so I highlighted it both green. So I know that's going to go in my numerator, and that is side E to F. Okay, now I got to find what corresponds to our small triangle A to C, which is my purple. So that means D to F corresponds to A to C. Okay, they're both on the bottom side of that triangle. So I'm going to set it up that same way. Okay, so within uses the same setup from the same figure. Okay, and we would read this as 6/7 is equal to 12/14. Okay, and then if I were to cross multiply to see if they're proportional, see 16 times 4 is 24, carry the 284. And then if I were to cross multiply this way, we still get 84. So they check off. They're proportional. All right, now an example with the between. Okay, you can use either way, the within or the between, but you'll still get the same answer. Okay, so the between ratio, is set up with two corresponding sides, but this time they're from the different figures. Before we did it within the same figure, now we're going to do it with different figures. So again, I'm going to highlight my B to C with the green. So the side that corresponds from B to C is E to F. Okay, they're on that right side of the triangle. Okay, so I'm going to set up, I'm going to go small triangle to my big triangle. Okay, if you do big in your numerator, that's fine. Just make sure you keep it the same. All right, so from my small triangle, our length is 6. From my big triangle, our length, oh my goodness, our length is 12. Okay. So now I'm going to go back to my small triangle. We had chose A to C before, which is our bottom part of the triangle. So what corresponds it to our bigger triangle is that same bottom. So A to C corresponds to side DF. So AC we get is 7. DF is 14. Okay, so our small triangles up top, our big triangles at the bottom. So here, if I wanted to see if they were proportional, I'll cross multiply, we get 84. Okay, and if I cross multiply the other way, we still get 84. So it checks off the same way. Okay, either way, you can use within or between. All right, our first example. Okay, here are your two similar figures. This is determine if the two figures are similar, provide a proportion to prove your answer. All right, so it doesn't matter which side you choose. Okay, so I'm going to label this one as my small triangle. Okay, here is my bigger triangle. So what I'm going to do is the between ratio. Okay, if you use the within, that's perfectly fine. It doesn't matter which one you use. Okay, so between is within the both of the shapes. So I'm going to just choose side AB. What corresponds to that side AB, okay, is X to Y. So small to big. So I said on the small side we chose was 4. What corresponds to that 4 is side 5. Okay, now I'm going to choose another side. I'm going to choose this bottom side here, B to C. Okay, so what corresponds B to C is Y to Z. If you notice, our bigger triangle is flipped and it's turned. Okay, so our small side we have is 6. What corresponds to the 6 is a 7.5. Okay, so now we want to prove our answer. So 7.5 times 4. Okay, we get 30. And then 6 times 5 is 30. So we proved that these triangles are similar. All right, example 2. We're going to determine if the two figures are similar and provide a proportion to prove our answer. So here, this is one of the main ones that you'll see, is where they'll have a triangle within a triangle. If you have to separate your triangles, do that. So here's my first triangle. Okay. My second triangle is this bigger one here on the outside. So if you can see it as it is, leave it as it is. But if you can't, you can redraw it to where you see two triangles. So that blue one, we have side A, B, C. This was 14. This is 10. Okay, and then we have our bigger triangle, which is A, D, and E. This was 15. 14 plus 8, we get 22. All right, so here, same thing as what we did before. I am going to do the within ratio this time. That way you see an example of both. So within is from the same shape. So A to B, I have 14. B to C, I have 10. Okay, so now you see what corresponds the same to my other shapes. So what corresponds A to B is A to D, which gives me 22 in my numerator. Okay, and what corresponds B to C is side D to E. It's both on that right side. So now that is 15. So if I were to cross multiply, okay, we get 220. And if I cross multiply here, 14 times 15. I do this wrong. 0, 2, 5, 6, 7, 0, 4, 1. I get 210. Did I multiply wrong? 20 times 10. 220. 22 times 10. Let me make sure I didn't multiply this wrong. It's supposed to be the same. 14. 15. Well, then I guess not. So then this one is not proportional. So if you figure out that it is proportional, let me know. Other than that, I'm going to go with not proportional since they are not equal to each other. We have 210 and 220. So if they're equal, then they will be proportional. Okay, so here's your you try. This is your exit ticket. Make sure you do it on a separate sheet of paper. Put your name on it and turn it in.